Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Good day, grade 9 learners. Welcome to today's Natural Sciences lesson. My name is Sianda Madala, and this lesson is brought to you by the Gauteng Department of Education. Right. So today we're going to be looking at the reactions of acids with metal oxides. In particular, metal oxides are bases, right? So we are still on the reactions of acids and bases. We just want to look at metal oxides as bases and their reaction with what? With acids. So this topic is also found under the strand, matter, and materials for our term 2. So now let's proceed. Now let's look at the lesson objectives. This is what we need to achieve by the end of this lesson. So by the end of this lesson, you should recall what a metal oxide is. So remember, in the previous lessons, we have done the reactions of acids, the reactions of metals with oxygen. So now we need to recall what metal oxides are. So we also have to remember the general reaction of metals with oxygen. So we're going to look at the general reactions of what? Metals with oxygen and some examples. We should also know the general wave equation for the reaction of acids with metal oxides. That is one of our objectives as well. We need to know the general weight equation for the reaction of acids with metal oxides. Lastly, we should explore examples of the reactions of acids with metal oxides. So we're going to look at examples of the reactions of acids with metal oxides. And all this information is found under the CAPS document, page 68. Right. Pre-knowledge. This is what we have done prior to today's lesson, right? So we use such information to build what? Foundation for our lesson. So you remember in grade 7 we did introduction to the periodic table of elements. We were talking about the elements like your hydrogen, oxygen, and so on, right? So we said this periodic table has a list of all the known elements so far. And we said that there are 118 so far. In grade 7 as well, we also did acids, bases, and neutrals, where we were testing different substances for their acidity or alkalinity, right? Then in grade 8, we did atoms, which are our building blocks of matter. In grade 9, we have done compounds and chemical reactions, and also acids and bases. So we use all this information to build up on today's knowledge or to build up on today's subject topic. Right. Lastly, previously we did reactions of acids and bases. Remember, when we're talking about the neutralization reaction, right? We said acids and bases counteract each other, or they overcome each other. Are we together? So now, baseline activity. Let's test ourselves using this baseline activity, right? The first question there says, what are metals? So we need to remember what metals are. Are we together? Number 2, where are metals located on the periodic table? So we need to remember where metals are located on the periodic table. 3, we have to write down the word equations showing reaction of oxygen with the following element. The element is magnesium. Number 4, so what do you think causes indigestion? And number 5, suggest one way in which indigestion can be treated. So now it's 5 questions, and I'm going to give you 5 minutes to complete the baseline activity. We'll meet again after 5 minutes. Welcome back, grade 9s. Now I hope you were able to answer the baseline activity questions, right? So now if you want to contact us for your answers or you have any questions, you can contact us on our number, which is 079 578 2908, right? That is our WhatsApp line. You can contact us there during this live. Right, let's look at the solutions. Now, baseline activity solutions. Number one, you had to tell us what are metals. So now, we did this, right? Metal is an element that is shiny in appearance. It is ductile, malleable, meaning it can change shape, and it is usually found on the left and towards the middle of the periodic table. Make yourself correct. Number two, where are the metals located on the periodic table? The answer is supposed to say on the left-hand side of the periodic table. Make yourself correct. Number three, write down the word equations showing the reaction of oxygen with the following element. The element is magnesium, right? So now you have to write down the reaction that has magnesium with oxygen. It is magnesium plus oxygen forming magnesium oxide. Then let's look at number four. Number four says, what do you think causes indigestion? We did this last time, right? So indigestion or heartburn is a result of unhealthy food or fizzy cold drinks. But why? This is because the fizzy cold drinks have what? Have a lot of acids. So indigestion is a result of the production of too much hydrochloric acid in the stomach. Make yourself correct. Number five, the last one. Suggest one way in which indigestion can be treated. So you can simply treat it by taking an antacid or a substance such as baking soda in water, because it is a base and it will neutralize the what? The acid in the stomach. Right, now, let's look at the important terms that you're going to come across here. Right? These terms are very much important because you're going to need them to understand today's topic. The first term we have there is metal oxide. So a metal oxide is a compound that is formed when a metal reacts with what? Oxygen. So we're trying to remind each other of what metal oxides are here. A metal oxide is a compound that is formed when a metal reacts with oxygen. So it is the product of metal and oxygen reacting together. Also, acids. An acid is a substance with a pH between 0 and 7. So it ranges from 0 to 7 on the pH scale to indicate what? Acidity. So it's any substance with a pH of 0 to 7 or between 0 and 7. A base. Now a base is a substance with a pH value of between 7 and 14. Then lastly, salt. Now salt is a crystal-like compound that forms from a reaction between an acid and a base. Are we together? It is a crystal-like compound that forms from a reaction between an acid and a base. So it is one of the products that is found when you react an acid and a base. Right, now, general reaction of metals with oxygen. Now remember our lesson objectives. We said we are going to remind each other of the reactions of metals with oxygen. So I want us to start there so that we understand and build up two acids reacting with what? With metal oxides. So now, the general reactions of metals with oxygen. When a substance reacts with oxygen, the reaction is called oxidation. It is called an oxidation reaction because we are simply oxidizing the what? The metal. So whatever substance that reacts with oxygen, the reaction is called oxidation Because we're adding what? Oxygen on top of the substance. Or we're reacting the substance with what? With oxygen. And as a result, a compound that is formed is called an oxide. So now, bear in mind here, we're still talking about any substance that reacts with what? With oxygen. It can be lithium with oxygen forming lithium oxide. Hydrogen with oxygen forming hydrogen oxide. Are we together? So any substance that reacts with oxygen, the reaction is oxidation, and that product will be an oxide. But now, because we're talking about metals with oxygen, so when you react a metal with oxygen that is found in the air, the metal oxide is formed as a result. It says here, when you burn a metal in air, the metal reacts with the oxygen in the air and a metal oxide is formed. So when we started, we said when a substance reacts with oxygen, the process is what? Oxidation, and the product is an oxide. So now specifically we're talking about a reaction of a metal and oxygen. So together they form what? A metal oxide. Now, it still depends on the metal that is in the reaction, right? It can be calcium oxide, it can be another metal oxide. But we will see more. We'll talk more about that. So now, the general reaction between a metal and oxygen is metal plus oxygen forming what? A metal oxide. So now we need to remember the general equations as well. That when you react a metal plus oxygen, we form what? A metal oxide before we substitute the weights there. So now, let's talk about the nature of combustion of different metals, right? So now, some metals burn more easily in oxygen than others, right? Some metals are not so reactive. So now, the level of reaction is different from metal to metal. So now, when metals burn in the excess of oxygen, I want you to observe what happens when a metal burns. First of all, you need to look at the appearance of the element before burning. Secondly, you need to look at the description of the flame, the color in which the flame is burning. And thirdly, you need to look at the appearance of the product. Now let's explore some examples. We're still talking about the formation of metal oxides, right? Calcium is one example of a metal. When it reacts with oxygen, it forms a white oxide named what? Calcium oxide. And that calcium oxide we are familiar with, it is used on our blackboards to write, right? What is that? That is our chalk, right? So if you look at this picture here, chalk color is similar to this picture, right? This is the white oxide that is formed when you react calcium with oxygen. And the name of it is calcium oxide. So I want you to notice this. Calcium oxide. We said the general reactions of metals with oxygen. It is metal plus oxygen forming a metal oxide. So in this case, the calcium is our metal, right? So it is calcium plus oxygen forming what? Calcium oxide. The second example then, magnesium with oxygen. So now when magnesium is burnt in air, it forms a white powder called magnesium oxide, right? So we keep this format, right? Metal oxide. The metal in this case is what? Magnesium. So magnesium oxide. So now I want us to look at this picture here. Here is a strip of magnesium burning in such a bright flame. And after that, it forms these ashes as a product. And these ashes are called our magnesium oxide because it is the product of this reaction here, right? So the product here is our magnesium oxide that is formed at the end. So now, I want us to look at the word equation for this reaction. It is magnesium plus oxygen forming magnesium oxide. Are we together, grade 9s? The symbol equation that is unbalanced. Remember, it is Mg plus O2 forming MgO. Mg is our magnesium, O2 is our oxygen, and MgO is our magnesium oxide. Now let's look at the balanced form of it, right? It is 2Mg plus O2 forming 2MgO. It's balanced because now there's an addition of coefficients in front of the element Mg and in front of the compound MgO, which is magnesium oxide, right? So 2 multiplied by 1 Mg, it's 2 magnesiums plus O2, 2 multiplied by 1 magnesium, 2 magnesiums, 2 multiplied by 1 oxygen, 2 oxygens. So we have done that part, right? So now, let's focus on today's topic now. We have talked about metal oxides, right, in terms of how they are formed. And I've reminded you of the examples. We've used magnesium plus oxygen forming magnesium oxide, calcium plus oxygen forming calcium oxide. So now, for today's topic, the fact of the matter is acids and metal oxides. Right, we have done acids and bases, right? We have talked about the fact that acids are rough and they taste sour and so on, right? So we want to see their reaction now with metal oxides. Now, first of all, metal oxides tend to react as bases. Hey, they tend to react as bases. Remember when we were doing neutralization reaction, what did we say about the reaction of acids and bases? We said acids and bases tend to what? To overcome each other, to counteract each other, or to neutralize each other. So it means what? When metal oxides tend to act or react as bases, they are reacting with acids in this case, right? What does it mean? It means they have the ability to make an acid less acidic. So it means what? They are neutralizing the acid. They are making the acid to be less acidic. So now, a whole product which was formed as a result of a reaction of a metal and oxygen. It is a base when it reacts with what? Acids. And it makes the acids to be less acidic. Let's keep that in mind. So now, also, when an acid reacts with a metal oxide, a salt and water forms. So now I want you to note the reactants here and the products. The reactants in this case are your acid plus a metal oxide. We don't know for sure at this point which metal oxide we're talking about, right? Or which acid we're talking about. But in general, an acid plus a metal oxide, those are your reactants together, right? The products that are formed at the end is a salt and water. So now, the type of salt also that we're talking about here, the type of salt depends on the acid and metal oxide that is used in the reaction. Why am I saying so? Let's go back to our lessons. We said that during a chemical reaction, no atom is added or omitted, right? What does this mean? They are simply rearranged, right? They are simply rearranged. So that's why the type of salt that is formed depends on the acid and the metal oxide that is in the reaction. So there's going to be a rearrangement of atoms from the acid and the metal oxide to give us the type of salt that we need. But we'll look more into that. Right. So now, during a reaction of acids and metal oxide, remember that a salt and water is formed. Now let's look at the general reaction for acids with metal oxides. The general reaction is metal oxide plus an acid forming the salt and water that I'm talking about. So we're going to explore examples now. Example of the metal oxide plus the acid reacting together, forming the type of salt that we don't know, and water. Right. The first example that we have there, we're going to look at its weight equation. we have magnesium oxide. Magnesium oxide we have talked about when we started our lesson. We said magnesium oxide is the product that is formed after reacting what? Magnesium plus oxygen. So therefore this one is our metal oxide plus our acid, which is hydrochloric acid, our HCl. They form magnesium chloride plus water. So now let's look at the chemical equation of it so that I can show you how the atoms are rearranged. So now here is a simple equation that is unbalanced here, right? MgO plus HCl forming MgCl2 plus H2O. If you look at this, MgO is what? Magnesium oxide. HCl is hydrochloric acid, forming MgCl2. Now the atoms, they've been rearranged, right? You find in this compound magnesium and 2 chlorine atoms. But in the first reactants there, chlorine was with what? It was with hydrogen. So there's some rearrangement now. Chlorine is now found with what? With magnesium, which gives us what? Magnesium chloride, which is a certain type of salt. So also the product here is what? It's H2O, which is water. So if you take note here, H2O has hydrogen and oxygen. The hydrogen comes from where? It comes from the hydrochloric acid here, right? So there's some rearrangement. Then the oxygen comes from this one here on the reactants. It comes from the magnesium oxide. Are we together? So now, here is a balanced chemical formula of it. MgO plus 2HCl forming MgCl2 plus H2O. So we're not going to dwell more on the balancing of equations because we have done this concept before, right? Now let's look at the pictures here. So here is our picture of magnesium oxide, right? This is magnesium oxide powder. It reacts, or it is plus the hydrochloric acid, right? Plus hydrochloric acid. Together they form salt and water. The salt in this case is what? Magnesium chloride, right? Look at this. It is crystal-like. As we said, that salt is crystal-like, right? So this is our magnesium chloride, right? Plus what? A molecule of water as well. So bear in mind that when you react magnesium oxide plus hydrochloric acid, you form magnesium chloride plus water. The general reaction is a metal oxide plus an acid forming a salt and water. Let's use another example so that we can be able to see the rearrangement of atoms that I'm talking about, right? And the salts that are formed. So now, the second one then, the word equation, we have calcium oxide. I want to remind you every time, calcium oxide is a form of metal oxide. Because what? Calcium is a metal which has reacted with what? Oxygen. That's why you say it's a calcium oxide. So this calcium oxide plus sulfuric acid. Sulfuric acid is a type of acid. And we said that the type of salt formed will depend on the acid and the metal oxide in the reaction, right? So calcium oxide plus sulfuric acid, they form calcium sulfate, right? Calcium sulfate is our type of salt. So they form calcium sulfate plus water. Let's look at the chemical equation or the symbol equation here, right? We're going to look straight at the balanced form of it, right? So now we have CaO. Ca, remember, it is calcium, right? So it's calcium oxide plus sulfuric acid, which is H2SO4, forming CaSO4 plus H2O. Now note the rearrangement of atoms. So calcium from the reactants, which was together with oxygen, it has now been rearranged and it is now with what? A sulfate, which is SO4. Are we together? Hydrogen, which was with the sulfate, it is now with the oxygen, which was initially found with the calcium oxide on the reactants. Are we together? Here is a picture again. Calcium oxide, which is our chalk, plus sulphuric acid, which is a very strong acid. They react together to form a crystal-like salt, which is calcium sulfate, plus water. Now, I hope we're getting this slowly but surely, right? The important part here is the rearrangement of atoms to determine the salt that is going to be formed. Right. Let's explore another example. Now, sodium oxide, which is a form of metal oxide, it reacts with nitric acid, right, to form sodium nitrate plus water. So now this is the simple equation which is unbalanced. Na2O plus HNO3 forming NaNO3 plus H2O. Now notice the rearrangement of atoms. It is very important, right? Na2, it is now with what? NaNO3 in the products, right? H is now with the oxygen that is found on the metal oxide on the reactants. So now, I want you to take a minute to try and balance this equation, right? So I'm giving you just 1 minute to balance this equation so that we can be able to continue. After 1 minute, we'll meet again. Now, welcome back, grade 9s. Remember to contact us. We are still waiting for your questions, right? 079 578 2908. That's where you get us, right? For your answers or any questions during this live, right? So now let's look at what we have tried, right? So now, I said balance the above equation. So now you have to put just a coefficient 2 here and 2 there, right? For our reactions of sodium oxide plus nitric acid forming sodium nitrate plus water. So let's see if it's balanced, right? So now we have 1 sodium here, we have 2 here, right? They all balance, right? So now check your coefficients as well. Now, let's move on. Right. Here is a picture illustration here of sodium oxide reacting with nitric acid to form sodium nitrate plus water. So the salt here is sodium nitrate. So now, reactions of acid with rust. Rust. Why am I saying rust? In the previous lessons, we've talked about rust, right? We said rust is a form of metal oxide, which is a result of ion reacting with oxygen. So you want to see what happens when acids react with rust. So now, this can happen. Strong acids can dissolve rust, right? They can dissolve rust. What does this mean? It means that we can use some acids to clean off rust. But depending on the strength of an acid, they can also dissolve paint, finish, and sometimes destroy the metal itself. So it depends on the strength of what? Of an acid. To either remove rust, dissolve the paint in which the metal was covered with, or also destroy the metal itself. Here is an example here of a reaction between nitric acid and copper. In this case, the acid is dissolving and destroying the metal, right? Hence, you see the brown color. We see that the copper is leaving the solution, right? It is evaporating because this acid is strong enough to dissolve and destroy the copper metal. So now, reactions of iron with oxygen. There's a reason why I put this here, right? Now, I want us to remember how rust is formed before we can talk about reactions of acids with rust deeply. So now, remember that rust is formed as a result of a reaction between iron with oxygen. So now, when iron reacts with air, right? Why do we say air? Because the oxygen is found in the air. And air is a mixture of other gases, right? Like your carbon dioxide, your argon, and so on, right? So now, particularly, we're talking about oxygen here. When it reacts with the iron, an iron oxide is formed. So iron and oxygen can combine in different ways as well. They can either form Fe2O3, which is rust, or they can either form magnetite. But today I want us to focus on rust, which is Fe2O3, right? So now Fe2O3 is our rust, and rust looks something like this. Look at this chain here, right? It has reacted with oxygen. It has reacted with oxygen, and as a result, it has given off this brownish color, which illustrates what? That it has rusted. So now, let's talk more about reactions of acids with rust. So now, when hydrochloric acid encounters iron, or when it reacts with iron, whether it is oxidized iron, meaning talking about rust, right? Or metallic iron, or just any iron, right? It wants to form the product iron chloride. Are we together? So therefore, when an acid reacts with metal, it tends to dissolve both the rust and the metal in order to form the iron chloride. So now, in terms of dissolving both the rust and the metal, it can be beneficial or harmful to the metal. What do I mean by that? It depends on the strength of the acid to either remove rust or destroy the metal itself. So now, if you were to carefully use dilute hydrochloric acid, you could dissolve away rust before dissolving the metal. So now, here's the key word here: dilute hydrochloric acid. So meaning that one can be beneficial for us to remove rust on our metals. Here's an example here, right? Let's look at these pliers. This is before, right? Looking at these pliers, it has rusted, right? It has reacted with oxygen, and it has formed iron oxide, which is Fe2O3 in this case, which is rust, right? It has rusted. But when you carefully use dilute hydrochloric acid, it can clean off the rust. It can dissolve the rust and go back to this form, right? It can go back to this form and become new again. Right. Now there are two chemical reactions taking place when reacting what? Acids with rust. It's what I've talked about, but let me explain further. First of all, the hydrochloric acid reacts with the rust. This is the case where I say it can be beneficial, right? It reacts with the rust to remove off the rust. Secondly, it is when it destroys the metal itself, right? So the first chemical reaction there, it's when the hydrochloric acid reacts with the rust. As you can see here, a symbolic chemical equation, which is HCl plus Fe2O3 forming FeCl3 plus 3H2O, right? And this equation is also balanced, right? Just to remind you, the above equation stands for hydrochloric acid with rust forming iron chloride plus water. So now, here is an illustration here of an X, right? An X which was rusted. So now you can try this at home as well. Remember acids and bases. So for those metals, you can either use vinegar as an example, right, of an acid. You can use vinegar as well. Soak the metals that have rusted for a number of hours, probably 12 hours, and to remove the rust, and it becomes what? Shiny again. As you see the X there, it has been removed from the acidic solution after 12 hours and it has regained its color. Moving on. The second one, we talked about what? The acid removing the rust first. So the second one is when it exposes the gray iron metal, which can then react, right, and destroy the metal. So now let's try and move on. So here is an illustration here, right, of a certain metal reacting with oxygen. Now look at this. It has been exposed, right? It is not covered with rust. So when it reacts with this acid, it starts to be eaten off slowly but surely. So this acid dissolves what? This metal. So now let's try and write these activities. Let's start by writing activity 1. The question reads as follows. Write down the general weight equation of metals with oxygen. Number 2, when the metal potassium reacts with oxygen, potassium oxide forms. So write down a weight equation for the reaction. Number 3, complete the weight equations for the reactions, right? The reactions are magnesium plus hydrochloric acid, they form P, it's iron plus hydrochloric acid, they form right? So now I'm going to give you 4 minutes to complete this activity. Now, I hope you were able to answer the questions, right? Let's look at the solutions. Number one, you had to write down the general reaction of metals with oxygen. And the answer is metal plus oxygen forming a metal oxide, right? Number two, when the metal potassium reacts with oxygen, potassium oxide forms. Write down a word equation for the above reaction. And the answer is potassium plus oxygen forming potassium oxide. Number three, you have to complete the word equations for the reactions below, right? Magnesium plus hydrochloric acid. The answer is they form magnesium chloride and water. Don't forget to mark your work. B. Iron plus hydrochloric acid forming iron chloride plus hydrogen. Right? So now let's move on to activity 2. This one is going to take only a minute. Let me read the question first, right? Write the symbol equation for the following reaction. The reaction is lithium plus oxygen forming lithium oxide. So you simply have to write a symbol equation for it. After 1 minute, we'll meet again. Welcome back, grade 9s. I hope you're enjoying these activities, right? Let's look at the solutions then. You had to write the symbol equation for the following reaction, right? Which is lithium plus oxygen forming lithium oxide. Your answer is supposed to be Li plus O2 forming Li2O, right? Lithium plus oxygen forming lithium oxide, right? So now I want us to engage on the last activity. This one I'm going to give you 5 minutes for it, right? But let's look at it. It says complete the table by filling in the names of the salts that would form when the following metals react with the following acids. Let me explain, right? Complete the table by filling in the names of the salts, right? You fill in the names of the salts that would form when the metals react with the following acids. So you have the acids here: nitric acid, sulphuric acid, and hydrochloric acid, right? The metals are what? Are magnesium, iron, and zinc. So you have to check this. Nitric acid reacting with magnesium. Nitric acid reacting with iron. Nitric acid reacting with zinc. And you do the same for the other acids. So let's meet again after 5 minutes. Welcome back, grade 9s. There's no responses so far, right? There's no questions. But why, guys? Contact us on 079 578 2908. Now let's look at the solutions, right? So you needed to complete the table by filling in the names of the salts that would form when the following metals react with the following acids, right? So we have nitric acid, HNO3. What would form as a salt when it reacts with magnesium? The answer is magnesium nitrate. Mark yourself correct. What would form when nitric acid reacts with iron? It is iron nitrate. Mark yourself as well. What would form when nitric acid reacts with zinc? It is zinc nitrate. I hope you got the first three correct, right? If you got the first three correct, it means you also got the other ones correct. Let's see. Sulphuric acid. What would form as a salt when it reacts with magnesium? It is magnesium sulfate. Mark your work. Sulphuric acid reacting with iron sulfate. Sulphuric acid reacting with zinc, it is zinc sulfate. Hydrochloric acid with magnesium, it is magnesium chloride. Hydrochloric acid with iron, it is iron chloride. Hydrochloric acid with zinc, it is zinc chloride. So I hope we're able to get correct answers, right? So now let's summarize today's lesson. Let's look at what we've been talking about today. So today we're mainly talking about the reactions of acids with metal oxides. So remember that we reminded you of metal oxides first, right? But the main focus for today was reactions of acids with metal oxides. So metal oxides tend to react as a base, right? That's what we're talking about here. We said that metal oxides tend to react as bases. So if you remember acids and bases, we said they neutralize each other. They counteract each other. So meaning when metal oxides react as bases with acids, they tend to make the acid less acidic, right? And we talked about the fact that when an acid reacts with a metal oxide, the products that are formed is a salt and water. On that issue, we highlighted that the salt that is formed depends on the acid and the metal oxide in the reaction. The acid and the metal oxide in the reaction, they will bring about the salt that will come as a product. As it says there, the type of salt depends on the acid and metal oxide that is used in the reaction. We also gave you the general reaction for acids with metal oxides. We said it is metal oxide plus acid forming a salt and water, right? So that is all for today. Let's meet again on the next lesson when we're talking about reactions of acids with metal hydroxides, right? We're going to talk more about now reactions of acids with metal hydroxides. So for now, keep on social distancing, wear your facial mask, sanitize, and have a good day.